Hello everyone, I hope you're doing well. This is Mr. O'Grady and we're going to talk a little bit about the product rule today. Before we can talk about the product rule of powers, we have to remind ourselves what a power is. So a power, some of you might think of it as an exponent, but a power is this entire part. The entire piece is called a power. So the entire thing is a power. And then within the power you have two different pieces. Most commonly known is this part right here, which is the exponent. So that's the exponent. Exponent right there. And then the x, some people call it the base. So this part we have the base. So the entire thing is called the power. Then the little exponent here, this little number up here, is your exponent, and then the x or number, whichever is down here, is called your base. The base is what gets repeated, and then the exponent tells you how many times you're going to repeat it. So in this case, our base is x. We're going to repeat x because that's our base. We're going to repeat that 3 times because our exponent is a 3. So if you're going to expand this out, x to the third would be x times x times x, just like that. When you write out the exponent like this, where we go x times x times x, we call that expanded form. So this is expanded form, and then when it's written out as x to the third, as it was previously written, that is called exponential form. You're not going to be quizzed or anything on these definitions, but they're just helpful to know when people are talking about expanded form and exponential form, just so you have an idea of what they're talking about. Now that we've reminded ourselves about the vocabulary for a power, now we can talk about the power product rule here. And the power product rule is just based off of if you're multiplying two powers, so if you have x to the third and you have x to the second, if we were going to multiply these together, the way that you could look at it is you could write x to the third in expanded form, so that would be x times x times x. And then you could write x to the second in expanded form, so it would be x times x. And then you can see here that when you're going to multiply these two things together, you have x times x times x times x times x. Well, how many x's are there? There are 5 x's. So if you're going to do the multiplication of x times x times x times x times x, and you wanted to write it in exponential form, you could say what's being repeated. That's your base. So the x is being repeated, so the x is your base. And then how many times is the x repeated? It's repeated 1, 2, 3, 4, 5 times. So then your exponent is 5. If you were to look at this, some of us might notice that if you have x to the third times x to the second, all we're really doing is adding these exponents together. So instead of writing x to the third out in expanded form and x to the second out in expanded form and then counting, you could just say, alright, there's going to be 3 x's here, there are 2 here, so then when you add 3 and 2 together, you get the 5. Let's look at another example. If you have x to the fourth times x to the 100th, you could write it out in expanded form if you wanted to, but then you'd have to be writing the x out 100 times. So the product rule saves us the hassle of having to write the x out 100 times. You could just say, alright, I know that this is going to be 4 x's multiplied. This is going to be 100 x's multiplied. If I multiply these 4 x's and these 100 x's together, then in total, I'm going to have 104 x's. So x to the fourth times x to the 100th is actually going to be x to the 104, because you can just add those two exponents together. So the product rule of powers, so the power product rule says that if you multiply powers with the same bases, you can add the exponents. So that's a quick way of getting what a product would be. Instead of having to write it down in expanded form, you could use this rule to figure out what the product of two powers would be. Let's look at a few more examples here of multiplying powers with the same basis. So if you have a x to the 5th times x to the 14th, hopefully by now you've seen and you can calculate that if you do x to the 5th times x to the 14th, we know that this is multiplying two powers with the same basis, so we can add their exponents. So x to the 5th times x to the 14th is going to give you x to the 19th. So that's pretty simple. But let's add some other variables into there to see if we can trick you up a little bit. If you have x to the 3rd and then y times x to the 5th, when you look at this here, we have x to the 3rd times y times x to the 5th. Some of you might think, oh no, we can't multiply these together because this has a y with it. But in multiplication, we can rearrange how we are multiplying the terms. And some of you might remember that if you have x to the 3rd times y, we can change this order using the commutative property. The commutative property says that if you have x to the 3rd times y, that's the same thing as y times x to the 3rd. So then we have y times x to the 3rd times x to the 5th. And now the x to the 3rd and the x to the 5th are next to each other. You're multiplying two powers with the same bases, so you can add their exponents. So this x to the 3rd times x to the 5th is going to give us x to the 8th. And now where we put this y doesn't change our answer, but in order for everyone to be writing their answers in the same way, we're supposed to write it in alphabetical order. So we're not going to put the y in the front, we're going to put the y after the 8, or after the x to the 8th. Another thing that can be confusing for people is that if you have a term like x y to the 3rd times x to the 5th y to the 6th, when you're looking at this one here, some people think that this 3 goes for both the x and the y, but it does not. And the reason why it doesn't go for the x and the y is because only the y is being raised to the 3rd power because there are no parentheses around the x and the y. If there were parentheses around the x and the y, then the 3 would also go for the x. But in this circumstance, there are no parentheses around the x and the y, so the 3 is only going to go for the y. And so when you look at the x, you need to think about what's that exponent going to be for the x. Well, if you just have an x hanging out there, how many times is the x repeated? Well, the x is only going to be repeated once. So your exponent is a 1. So the exponent of the x is a 1. The exponent of the y here is a 3. And then we can look here and say, the exponent of this is a 5, and the exponent of this is a 6. If we wanted to rearrange them all, we could. But we know that we could, so we don't need to rearrange them. But if you wanted to, you could write it like this, using the commutative property. Since this is multiplication, and this is multiplication, and this is multiplication, we could just switch these two things around. And so this would be x to the 1st times x to the 5th times y to the 3rd times y to the 6th. And then you can look at this and say, alright, x to the 1st times x to the 5th. Using the product rule, we're just going to add their exponents, so that's going to be x to the 6th. And then using the product rule here for y to the 3rd times y to the 6th, that's going to give us y to the 9th. We can expand this out even further and do even more. So this was one term times one term, but you could do as many terms as you want. And the rule is going to be the same. If you're multiplying powers with the same bases, then you're going to be able to add their exponents. So if you have an x to the 1st times this x to the 5th, that's going to give you the x to the 6th. If you have the y to the 3rd times the y to the 6th, that's going to give us the y to the 9th. And that's going to be the same no matter how many you out. So if you had x to the 3rd y to the 4th, x to the 5th, y to the 7th, x to the 100, y to the 3rd, another y to the 5th. If you're going to do it like that, you just say, all right, how many x's are here? Well, there's 3 x's here. How many x's are here? There's 5 x's. So together, this x to the 3rd times x to the 5th would give you x to the 8th. Then you go down the line and you say, oh, there's another x. That's x to the 100th. So if this was x to the 8th, x to the 8th times x to the 100th is going to give you x to the 108. And then we can do the exact same thing with the y's. You look at the y to the 4th, y to the 7th, that's going to give you y to the 11th. Y to the 11th times y to the 3rd is going to give you y to the 14th. Y to the 14th times y to the 5th is going to give you y to the 19th. Another thing, maybe you might be confused if we are using parentheses or not using parentheses. That doesn't matter. Parentheses is one way to show multiplication of one term times another term. You could put parentheses around all of these if you wanted to. So you could write it like this and put a parenthesis there and a parenthesis there. Or you could put a parenthesis around these two things. The parentheses don't matter. If you see two things next to each other and they're in parentheses, or one of them is in parentheses, that means they're going to be doing multiplication. So it doesn't matter if those parentheses are there or not. Alright, let's look at some powers that also have coefficients attached to them. So we're going to be looking at terms that have powers and coefficients. So if we have 3x to the 5th and we want to multiply that times 2x to the 7th. One thing that confuses people is that they hear a product rule, so we need to add, and then they start adding everything. But that's not what you do. The only time you're going to add is if you have the power times the power, and they share a base that's similar, then you can add their exponents. With the coefficients, the numbers that are in front, the numbers that are not being raised through power, with the coefficients, you're just going to multiply them like you normally would. So this would just be 3 times 2. So 3 times 2 would give us 6. And then x to the 5th times x to the 7th is going to give us x to the 12th. Let's look at another one. 4x y to the 3rd times 2x to the 2nd y to the 5th. If we're looking at this one, we're going to multiply the coefficients. So you're going to go 4 times 2. That gives you 8. This x, remember, don't get tricked. This x is being raised to the first power. That x is to the first power. If you want to write a little 1 there, you can. So this is x to the first times x to the second. That's going to give us x to the 3rd. And then y to the 3rd times y to the 5th is going to give us y to the 8th. And so what you could do, if you wanted to, you could group all these together. So you could say, all right, here's a 4 and that's a 2. I'll write this 4 times 2. And this is an x to the first, and this is an x to the second. So I can write x to the first times x to the second. And then this is a y to the third and a y to the fifth. So I'll do y to the third times y to the fifth. So if you're having trouble keeping up with what's going on, you could write it out like this if you'd like. So you're going to do the 4 times 2. That's going to give you the 8. The x to the first times x to the second is going to give you x to the third. The y to the third times y to the fifth gives you y to the 8th, and that's where, that's the same answer that we came up with up here. But if you are having a hard time getting this, you could write it out like this so that you could see the different parts of it. Some common mistakes that people make. So common mistakes when people are multiplying powers is that when you have two terms, like 3x to the 5th times 7x to the 10th, they see that we have the same bases in both of these, and so they'll say, all right, x to the 5th times x to the 10th, I can add the exponents, and that gives me x to the 15th. And then they say, all right, 3 and 7, I'm going to add those together and give me 10. But that is not correct. That's a no. That's not correct because with the 3 and the 7, you're still doing multiplication. This is still multiplication, and so the rules are still going to apply that we use for multiplication. And so 3 times 7 is going to give us 21, not 10. So this is not supposed to be 10. This is supposed to be 21x to the 15th. The other common mistake that people make when multiplying powers is something that we talked about earlier. If you have a term like xy to the 5th, and we're going to multiply that times 7x to the 3rd, y to the 4th. If we're multiplying these two terms together, people say, alright, there's no number here, so this would be a 1, because there's one of these terms here, so you could put a 1 there if you want. You do 1 times 7, you get 7. And then when they do the x's, they think it's x to the 8th, but it is not x to the 8th, because when you look at this, the y is being raised to the 5th power, but the x is not being raised to the 5th power. The reason why the x is not being raised to the 5th power is because there aren't parentheses around the x and the y. Since there are no parentheses, the 5 only goes for the y, it doesn't go for the x as well. So this x is actually being raised to the 1st power. So this is x to the 1st power times x to the 3rd power, and that's going to give us x to the 4th power. Okay, so don't get confused and think that the x is also being raised to the 5th power. The only thing that's being raised to the 5th power here is the y. Another thing that could be confusing, I realized when I am writing this, is that when you're multiplying terms together, it doesn't matter how you write it. You could put a dot in between or parentheses in between, it doesn't matter. So if I want to do x to the 5th times y to the 3rd times x to the 7th times x to the 5th y to the 3rd times x to the 4th, whether you're using parentheses or the dot or if you're writing them next to each other, it doesn't really matter. It all means multiplication. Since it's multiplication, you can use the product rule as long as you have the same bases. And so when you look here, you have an x for a base, you have x for a base here, you have x for a base here, and x for a base here. So you can add up all these exponents of the x's. So 5 plus 7 is 12, plus 5 is 17, plus 4 is 21. So this is going to be x to the 21st, and then y to the 3rd times this y to the 3rd is going to give us y to the 6th.
I hope you had the time of your life. So take the photographs and still frames in your mind, hang it on a shelf in good